High-tier data science roles can reach a total value of $600,000 per year, provided you understand the financial mechanics tech companies use. That $500,000 figure is rarely a flat cash salary. In the tech industry, these payouts are defined as total compensation, or TC. Total compensation splits into three streams: base salary, an annual bonus, and restricted stock units, or RSUs. Watch the stock portion. A base salary scales because RSUs vest on a 4-year schedule. As the company grows, these shares compound significantly. Reaching these numbers relies on this equity structure. You are capturing ownership in a high-growth corporation rather than only trading your hours for a wage. To see how these mechanics work in practice, let's look at the career trajectory of data scientist Priya. She graduated from a mid-tier state college and started in an analytics role paying $45,000 a year. Looking at the tech giants from that desk, the distance felt insurmountable. Hearing about $500,000 packages triggered a sense of imposter syndrome, making those roles feel reserved for a different class of engineer. Moving from a $45,000 baseline to a top-tier package requires a shift in how you demonstrate your value to the market. Priya stepped away from the traditional path of collecting degrees and focused her energy on building a public record of what she could actually produce. She bypassed general theory to master 4 specific production skills: Python programming, SQL databases, A/B testing, and product sense. She wrote code to solve business-critical problems, like predicting customer churn and tracking sales performance, and published the underlying logic publicly on GitHub. In high-stakes hiring, a repository of applied working solutions carries more weight than the name of the college on a diploma. 4 years into her career, her portfolio landed her an interview at a major tech firm. But she immediately hit a wall. The big tech interview process is a 5-round gauntlet. It tests your proficiency in SQL, your understanding of machine learning system design, and your behavioral alignment using the STAR method. This sequence maps those hurdles. Most candidates clear the early tests, but fail at gate number 4, machine learning system design. Here, you build algorithm nodes from the ground up. Priya spent weeks practicing how to write and scale algorithms without prepackaged code libraries. Surviving this loop means proving you can take a theoretical concept and make it perform for billions of users, a skill rarely prioritized in standard university programs. After clearing the final round, she received an initial total compensation offer of $455,000. When faced with an offer that large, the immediate instinct is to accept out of relief. However, the final stage requires professional distance. You take time to review the contract, research the role's full salary range, and prepare a request for a 10 to 20% increase. You justify that increase by mapping your technical proof of work to the hiring team's most urgent business goals. You spent years building the expertise to pass their technical gauntlet. Failing to negotiate at the finish line means leaving value on the table. By holding firm, Priya secured a revised total compensation package of $545,000. This graph plots that package over time. When you factor in the projected growth of her vested shares, she is crossing the $600,000 threshold. She reached this level by focusing on production-grade skills and navigating the specific rules of the high-tier hiring process. This level of compensation is the result of surviving a technical gauntlet that bridges the gap between theoretical research and large-scale production.